Binomial is when you have two terms that are added or subtracted together, and when you multiply binomials, then we have a special way to do that. We can show that diagrammatically, where we use our arrows to multiply in order, or we could show it over here like on the graph. So essentially when we're multiplying things, we use the same rule we would do if we were expanding something like 2x plus 4. We would multiply 2 times x, and then we would multiply 2 times 4, and we could expand that. So when we have two binomials next to each other, if they're next to each other, then we presume that we are multiplying them. That's what that means. And so we're going to do the same thing as we're going to multiply the first by the first, and then the outside ones. Then we're going to go to the second one, and the first one there, and the second one there. Another way to think of it is FOIL. So again, you're going to do the first ones, that's the first arrow, then the outer ones, that's the O, then the inner ones, that's the I, and then the last ones. Now, it doesn't really matter the order that you do it in, because you're just going to add them all together, and we know adding is associative, but you really need to be careful and keep your signs with them. These are all pluses, but when we get into negatives, we need to carry them with them. So as you can see, first we do A times C, and we get AC. And if we were to map that out, one side of this would be A plus C of this diagram, and the other length would be C plus D. And that's what we're multiplying, because remember that area equals length times width. So the length is going to be, in this case, A plus B times the width, C plus D. And as you can see that we're going to do A times C, and we're going to add A times D, because this is also A length, and this is D. And to that we're going to add just this B length times just this C length. And to that we're going to add just this B length times just this D length. And so then we add all those together and we get our total area. That's another way to think of it. So if you're happy to just use the FOIL method, if we did this x times this x, that gives us x squared. And then we take that first x times 5, and that gives us 5x's. The FOIL method is really good because you'll see that it keeps our like terms together in the middle. So 1 times x is just plain old x, which is that second term here, and then 1 times 5 is 5. So we gather these terms, and this is as far as we can go. We can get 5x plus 1x is 6x's, and that's our answer. So for A, we're going to have the first binomial x plus 3 times, because it's next to it, it's times x plus 5. So let's do it in order. First is the FOIL. That gives us x to the power of 2, x squared, and then the outers. So we're going to add 5x's to that, and we often like to do then underneath 3 times x, so we've got 3x's there, plus 3 times 5, which is 15. Now you can see in the middle here that we've got some like terms that we can combine, so that gives us x squared plus 5x's and 3x's is 8x's plus 15, and we've got it, we're done. We'll go over here to B. B is going to be x minus 4, or x plus negative 4, and x plus 7. So we've got to be real careful that we keep the sign with that term. So the first thing we're going to do is the first in each set, which is x times x, which is x squared. And then after that, we've got x times 7. So we're going to add 7 x's here. Now we've got, careful here, we've got negative 4x. So if I've got, remember these stay together. Negative 4 times x means we've got adding negative 4x, or we could say minus 4x, which I think makes more sense. And then negative 4 times positive 7 is going to give us 28, and it's going to be negative because we've got a negative 4 and then a positive number. So again, we can combine these things. X squared plus 7x's, take away 4x's, leaves us 3x's, and we're still going to be minus 28. We can't do anything about that. Okay, we're on a roll. Now for C, we're looking at 2x's minus 1 times x minus 6. So we've got two minuses in here. So now we've got 2x times x. And so we've got 2 times x times x. So we have 2 times x squared. Not in brackets, it's just the x that's squared. And then we have 2x times negative 6. So that means minus 12x's, or plus negative 12x. And now we've got negative 1 times x. So we take away 1x, we don't write the 1. And then we have negative 1 times negative 6. Negative makes a positive, so we get positive. This is where we often get tripped up. 2x squared, 12x's minus another x is 13x's plus 6. That's C. And then finally we have for D, that's a D, 5x's minus 2, and that's multiplied by 3x's plus 7. So we've got a little combination. First one is 5x's times 3x's, which in a way we think is 5 times 3 times x times x. That's how I like to think of it. So that's where we get the 15, 5 times 3, and then x squared. Then we've got 5x times 7, so that makes 5 times 7 times x is 35x. Now we're going to be plus or minus. We've got a negative 2 times 3x. Negative positive means negative 6x's. And then we've got a negative times a positive again, so we're going to take away 14. So 7 times 2 is 14, but it's a negative 2. And now what can we put together? 5x squared. And we're still going to be plus, is that 29x's? 35x's minus 6x's minus 14. Once again, just to make that clear, if we've got 5x's times 3x's, that's the same as 5 times 3 times x times x. That's really hard to see. And that's how we ended up with 15x times x is x squared. Okay?